Okay, welcome everyone. We are running. Today is our first day of sequences, section 13-1. And boy, the work there in example 3 is a little bit, it's not confusing, but the authors just chose to leave a bunch out. Remind me, Trevor, how that looks. It was like T sub 3 equals 12, and what else did they give us? T sub 6 equals 96. I think they said give us T sub 11. Yeah, equals find it. Okay, and then and did it tell us if this is arithmetic or geometric? Okay, so that's really important, geometric. Now, for geometric sequences, did they give us some kind of an equation that we can work with? T sub n equals, wasn't it like T sub 1 r to the n minus 1? Is that the one? Okay, where'd you find that, Trevor? Okay, so that's from page 474 if you don't have that in your notes, and hopefully you all do at this point. Remember, when I write on the board to read the section and write the notes, that means you do that last night, and that makes a huge difference because then you come to class ready to rock and roll. Okay, so let's plug in two different equations here and see what we can do with it. Okay, so we can say T sub n, we know a couple. We could say T sub 3 equals T sub 1 times, that's a T. Golly, that's ugly. Yeah, T sub 1 times, do we know the ratio? No, not yet. Times r to the 3 minus 1, yeah? And then they did give us T sub 3, so we can say 12 equals T sub 1 times r squared. True? You believe me? Okay, good. That's important. Now, then on the other side, we can say T sub 6 equals T sub 1 times r to the 6 minus 1. And then T sub 6 was 96 equals T sub 1 times r to the 5th. Looking better. Looking better, man. I think we can figure something out for this. So then we can say 12 equals T sub 1 r squared, and we can say 96 equals T sub 1 r to the 5th. So far, so good? Okay. Now, I see a T sub 1 in each one. Yeah? So then what could I do? Because they always say, like, if you have two unknowns, in this term we have T sub 1 is unknown and r is unknown. If you have two unknowns, you're going to need two equations. Have you heard that term? Or maybe from Algebra 2, you remember that? Two unknowns, two equations. And we have that situation. We have one here and one here. And there's a bunch of different ways you can solve them. There's a bunch of different ways. I think we should solve for T sub 1. Okay? In each case. So here, in this, the black version, what would T sub 1 equal? So we could say T sub 1 equals 12 over r squared. Is Jorge nuts? Most likely, but is he right in this case? He divided both sides by r squared. Is that legal? Yes. In Oregon. Good answer. Gosh, I feel sorry for you all. They're legalizing everything around here. Anyway, and then we would have t sub 1 on this side equals what? 96 over r to the 5th. Is that correct? We divide both sides by r to the 5th. Does that work? Don't just nod your head. Tell me if you don't believe it. Okay? So check this out. This is really interesting, everybody. Now, we can take, I have a t sub 1 here and I have a t sub 1 here. That means I could take this and substitute it for t sub 1. True? I mean, is 96 over r to the 5th equal to t sub 1? So that means anytime, anywhere on the whole planet that I see a t sub 1, I can put this in instead. Substitute it in. Okay? So now, holy smokes, that means I can say 96 over r to the 5th equals 12 over r squared. I believe it. Yeah. And all of that, I'm just off to the side, I'm going to say equals t sub 1. But for right now, let's solve for r. This right now, I have one equation and I have one unknown. Okay? So this is cool. Now, how can I solve for r here? Gabino, what do you think? You can cross multiply if you want to, but if you don't like that, because cross multiplication is, you know, sometimes people forget. But you can cross multiply totally. But really, 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 where does cross multiplication come from? Really. Say it, Calvin, with a little more force. Multiplying by the reciprocal. Really is where cross multiplication comes from. So I can multiply by the reciprocal, which is r to the 5th over 96. Whatever I do on that side of the equal sign, I have to do over here on this side of the equation to keep it that way. R to the 5th over 96. And really, when you're cross multiplying, Gabino, that's what you're doing. So you were right. You can cross multiply. Now, what does all this mess over here equal? 1. It doesn't just cancel. It equals 1. God, I brain farted so bad last period. Mr. Hartman was back there just shaking his head going, what a mess. Okay, this is 1. This is 1. So this is 1 over 1. It doesn't evil C word. Equals 12r to the 5th over 96r squared. Okay? We're doing well. 1 over 1? Think easy. 1 equals. Okay, now, what, 12 over 96? Boy, those numbers, they just feel like, you know, Claire, like they reduce. 12 over 96. That reduces, I know it. Heaven, what number jumps out at you? 12 over 96, Connor? 1/8. That's 1/8. So that's 1/8. And then r to the 5th over r squared. R to the 5th over r squared. Yeah, r to the 3rd. Okay, so now we have 1 equals r to the 3rd over 8. It's looking better. Next. Casey, what up? Yeah. What's the next step, Casey? Thank you, Casey. Multiply both sides by 8, and we get 8 equals r cubed, Sarah. What's r equal? Cube root. Yeah, cube root of what? 8. So R equals 2. Sweet! Dudes and dudettes, we just found the common ratio. Common ratio for a geometric series. Or sequence. Sorry, we're not to series yet. Hey, I feel good. I'm happy. I feel good. So then what would the next... I can't even remember. Trevor, way back in the day. T sub 11. We need T11. T sub 11. So then we could say T sub 11 equals T sub 1. Oh, man. Times 2 to the 11 minus 1. Oh, that means we have to find T sub 1. Rats! Well, let's just hold this. Let's just table this till later. How can we find T sub 1? Oh, no way. T sub, yeah, way. T sub 3 equals what, Sarah? Well, it'd be T sub 1 times 2 to the 3 minus 1. And it is 12, so that equals T sub 1 times 2 squared. So 12 equals T sub 1 times 4. It's looking better. ¿Qué más? Divide by 4, T sub 1 equals 3. Okay? T sub 1 equals 3. So then we're saying T sub 11 equals 3 times 2 to the 10th. And you can get your neighbor to figure that one out for you. That's a bunch. That's a bunch. Okay, Daniel, what'd you get when you did all that? Yeah. Man, you are so lucky that Hannah has your back. 3,000 and how much? 72. Anybody check that? I don't believe Hannah ever. Good. Okay, good job, Hannah. Okay, so there's T sub 11, but you know, for as a bonus, let's think of this. We said T sub 1 was 3. T sub 2 then would be what? Common ratio. Common ratio. What was it? 2. So then T sub 2 is 6. T sub 3 should be 6 times 2. Really? Yeah, that's how it goes. Times 2, 24, dot, 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 3,072. Sweet. That's how it goes. Trevor, does that help? Yeah, I got to tell you, when I looked in the book and it was like 4 lines long, and how much did we take? Sometimes it's good to show your work. Okay, that is all. This will be posted on our website if you choose to watch it. It's 14 minutes long.